10 simple radical equations. Guys, when we want to solve this, you have to isolate the square root sign. Okay, you have to isolate the radical. You've got to get it by itself. Then once you do, you just square both sides to get rid of the square root sign and then solve for the variable. Okay, now there's a little tweak that I'll need to show you when we get to the third example, but this stuff looks pretty straightforward. Let me show you. I'm going to rewrite this just so that I'm not messing with the words over there. So I've got 140 is equal to the square root of 2 times 9.8 times d. Okay? Now, first thing I'm going to do, guys, is I'm going to simplify the stuff underneath the radical. I don't know why they've got it like that, but let's say we've got 140 is equal to the square root. What is that? Is that 19.6? Right? 19.6 d. Okay? Okay. There we go. Okay, that looks pretty messy. Let me see if I can fix that. D. Alright, that's better. Now, once I've multiplied these two, I've simplified everything under the square root sign, the square root sign. It's by itself. Okay? So I'm going to square this side, and I'm going to square this side. Alright? Now 140 squared, I'm going to get out my old trusty TI-34 here. Alright, and I'm going to do 140 squared, and I get 19,600 teachers. Look at that. Okay? Now, on this side, remember, whenever I square a square root sign, it just goes away. Okay, so that just goes away, and it leaves me with 19.6d. Alright, I'm going to divide both sides by 19.6. Divide this by 19.6, and I get that d is equal to, what is that, 1,000? Okay. Perfect. Perfect. Okay? Easy stuff. Remember, get the square root by itself, then square both sides, and then solve for the variable. Okay? Now, let's look at the next one. Now, see, here's an example. Let me rewrite it. All right? It's the square root of 5x plus 1 plus 2 is equal to 6. Now you'll see the plus 2 is not under the radical. So I need to, like I do with absolute values, I need to subtract 2 from both sides and isolate the square root. So now I've got the square root of 5x plus 1 is equal to 4. Okay, now I've isolated that square root. So I'm going to square this side, which gets rid of the square root, and I'm going to square this side. So that gives me 5x plus 1 is equal to 16. I'm going to subtract 1 from both sides, and I get 5x is equal to 15, divide by 5, and x is equal to 3. Now, before we go on, guys, think about this for a moment. Whenever I square a number, it's always positive. Okay? So if I square 3, I'm going to get positive 9. If I square negative 3, I'm going to get positive 9. Okay? Squaring it can sometimes change the sign, which means that it sometimes changes the equation. Okay? Some answers that I get may not actually solve the original equation. But I will always get the answer. But not every solution that I get when I square things might solve the original, but one of them will. At least one of them will. So all of that's just to say you need to check your answer. Okay? So let's go back in here. Let's make sure that that 3 works. All right? So I'm going to get 5 times 3 plus 1. Okay? So that's going to be the square root of 15 plus 1 plus 2 is equal to 6. The square root of 16 plus 2 is equal to 6. 4 plus 2 is equal to 6. 6 equals 6. Boom. Done. Nice. Okay? But let's look at this next example, and you'll get a better idea of what I mean. You'll always get the solution. It'll be one of them. Okay? But not all of them necessarily work. So let's look at the next example. All right, first thing, when you square both sides of an equation, the new equation may not be equivalent to the original equation. That's because we're squaring it. Sometimes it'll change negatives to positives. Okay? Therefore, you must check every possible root or solution in the original equation to see whether it is indeed a solution. Here's something that you need to know. Root, solution, and x-intercept are all synonyms. Okay? They all mean the same thing. If I'm graphing it, right, I call this the x-intercept. The x-intercepts. These numbers are the roots, or the solutions to the equation of this graph. Okay? All right. Now, let's look at this. Example number 3. I'm going to rewrite it. It says the square root of 11x squared minus 63 minus 2x is equal to 0. All right? First thing, let's get the square root by itself. Remember, we have to isolate it. So I'm going to add 2x to both sides. And I'm going to get the square root of 11x squared minus 63 is equal to 2x. Now I'm going to square both sides to get rid of that square root. And that's going to give me 11x squared minus 63. But remember, it's 2x squared, or 2x times 2x, which gives me 4x squared. Okay? Now, I'm going to subtract 4x squared from both sides. And that's going to give me 7x squared minus 63 is equal to 0. Okay? Now, when I have the quadratic like this, when it's the only thing, right, there's not another term with an x in there, I'm going to get it by itself. So let's add 63 to both sides. That's going to give me 7x squared is equal to 63. Let's divide by 7, and I'm going to get x squared is equal to 9. All right, we're almost there. I want to know what x equals. I take the square root of both sides, but remember, when I take the square root of a variable, I need to give the positive and the negative. So x equals plus 3 or minus 3. Now, I know that at least one of these is the solution. Maybe both. Maybe both. But one of them may not be. I know that one of them is, at least. Let's plug it in to the original and see. Okay? Let's check positive 3 first. Square root of 11 times 3 squared minus 63 minus 2 times 3 is equal to 0. All right, let's see. Square root of 11 times 9 minus 63 minus 6 equals 0. The square root of 99 minus 63 minus 6 is equal to 0. The square root of 36 minus 6 is equal to 0. 6 minus 6 is equal to 0. 0 equals 0. Nice. So 3 definitely works. Bing! That's one. Let's see if the other one works. Okay? Now, I'm going to erase this and I'll just try the other one. Alright? Square root of 11 times negative 3 squared minus 63 minus 2 times negative 3 is equal to 0. See how these signs matter? That's the thing. Once we start squaring it, we're getting rid of some negatives, but when we plug it back in, they may not work. Okay, so let's see. Square root of 11 times 9 minus 63 plus 6 equals 0. Square root of 99 minus 63 plus 6 equals 0. Square root of 36 plus 6 equals 0. 6 plus 6 equals 0. 12 equals 0. That's not true. Negative 3 doesn't work. Only positive 3 works. Okay? All right. Nice job. You guys have done, that's all we really need to know about solving simple radical equations. All right? Let's see, is there another example? That's it. All right, you guys are good. Good luck with your work, and I will see you tomorrow.